Hello and welcome. In this video, we will provide an overview of Proactive Network Disqualification. PowerFlex is a highly distributed architecture. When a port or a socket experiences frequent disconnects, system performance can be impacted. PowerFlex detects this condition and proactively disqualifies the path, preventing general disruption across the system. Now let's take a closer look by demonstrating this improvement. Looking at the performance profile of our PowerFlex system, we see we have a relatively consistent 80,000 IOPS. Now let's look at our PowerFlex topology. The top half is the SDC configuration and below an SDS. Highlighted in red is the 192 SDC only network, in green the 172 SDC only network. For this exercise, we will introduce a port flapping issue with SDC interface ENS161. First, we will disable the port flap feature using SCLI. In essence, we now have a PowerFlex system that will behave much like PowerFlex 3.5. Note the tech option must be used to disable this feature. Next, we will simulate a port flap issue by randomly taking ENS161 offline and online using a shell script on our SDC system. Now let's focus on the SDC performance. As expected, we immediately see impact on ENS161. However, the port flap issue on ENS161 is also impacting the performance on ENS193. Switching to the PowerFlex UI, we see the impact of the SDC port flap. Note that as long as the SDC port is flapping, this performance degradation will continue. For the next step in this exercise, we will resolve the port flap issue by stopping our script on the SDC system and ensure that the interface ENS161 is enabled. From the SDS, we will use SCLI to enable the port flap feature as seen here. We can monitor portal qualification by running SCLI with the query port flapping status option. For this exercise, we are using the watch command to monitor the SCLI query output. From the SDC, we will introduce the port flap issue on ENS161 and monitor the results. We notice that the initial behavior is much the same. The ENS161 flapping port is still impacting ENS193. However, once ERT/ERTF thresholds are exceeded, we will see the portals being disqualified, as seen in the output of the SCLI query port flapping status command. Now that the portals have been disqualified, we see that the port flapping on ENS161 is no longer impacting ENS193. Looking at the performance impact, we see a significant improvement with PowerFlex 3.6 port flapping being enabled. Remember, in a pre-3.6 PowerFlex system, that the performance impact will persist as long as the port flapping issue exists. Switching back to our CLI output, we will resolve the port flapping by stopping the script and enabling the interface on the SDC. Now that the flapping port has been resolved, the portals will go through the requalification process before being brought back online. We can see that our portals have completed the requalification process, and SDC I/O is evenly distributed across both interfaces. A new alert has been introduced to notify PowerFlex administrators that ports have been disqualified, as seen here. That concludes the overview of Proactive Network Disqualification in PowerFlex.